Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing questions based on atoms and molecules, atomic mass, molecular mass, mole concept, determination of chemical formula. I have discussed up to question number 64. Now I will continue from question number 65. I will tell the question number 65. The crystalline salt Na2SO4 XH2O on heating loses 55.9% of its weight. The formula of the crystalline salt is, four options are given. First, sodium sulfate 5H2O. Second, Na2SO4 7H2O. Third, Na2SO4 10H2O. And fourth one is none of these. Okay, now you have to answer. Again I am telling you one more time question. The crystalline salt Na2SO4 XH2O on heating loses 55.9% of its weight. The formula of the crystalline salt is option 1 Na2SO4 5H2O, second Na2SO4 7H2O, third Na2SO4 10H2O, and fourth one is none of these. Just to think and answer. Okay. Now I am telling you correct answer I will tell you. Okay. Then here first I will give explanation, then I will tell you these things, which option is correct. See, 55.9% on heating loses 55.9% of its weight. Correct? Suppose its weight was 100 gram. Then now it loses 55.9% of its weight. Means 100 minus 55.9%. Now it is remaining. 100% of crystalline salt contains H2O. Means that loss is due to the water molecules. That is a 55.9 gram out of 100. Suppose its mass was 100 total. Then in that it lost 55.9 gram. Then anhydrous salt will be how much? Anhydrous means without water. Then anhydrous salt is equal to 100 minus 55.9. That is equal to 44.1 gram. This is the weight of anhydrous salt. Molecular mass of anhydrous sodium sulfate Na2SO4. What will be the molecular mass of anhydrous sodium sulfate Na2SO4? Then 2 into 23 plus 32 due to the sulfur plus 64. 64 means 4 into 16. You add all, it will become 142. Means 2 into 23, 46. Plus sulfur is there, one sulfur, that is 32, plus 64. SO4, O4 means 4 into 16. After adding, its value will become 142. This is the molecular mass. Then now we have seen anhydrous salt is 44.1 gram. Then 44.1 gram of anhydrous salt combines with H2O, means it combines with 55.9 gram water. 44.1 gram of anhydrous salt combines with H2O, that is a 55.9 gram. Then 142 gram, it will combine with how much water? Then it will be 55.9 divided by 44.1 into 142. Correct? 142 gram, this 44.1 gram of anhydrous salt combines with 55.9 gram water. Then 142 gram anhydrous salt will combine with how much H2O? Then 55.9 divided by 44.1 into 142, upside 142. Then it will become 180 gram. Means it will combine with 180 gram of water. Then 180 gram water means what? How much? Then 180, if you will divide by 18, then it will become 10 molecule. 180 divided by 18. 18 gram is equal to 1 mole. 1 mole. Then 180 divided by 18, that is the 10 molecule. It means X value is 10. 10 molecule of H2O is attached. Hence question correct answer will be how much? That is the option C. Option C, that is Na2SO4 10H2O. That is the value of X. Okay, question was the crystalline salt Na2SO4 XH2O on heating loses 55.9% of its weight. The formula of the crystalline salt is, now I solved, it is Na2SO4 10H2O. I have explained, I have solved the numericals. Now next question I am telling you. Question number 66. At NTP, means normal temperature and pressure, 5.6 liter of gas weigh 8 gram. The vapor density of the gas is, vapor density of the gas is, first option is 32, second option is 40, third option is 16 gram, only 16, don't gram. And option D is 8. First option is 32, second option is 40, third option is 16, fourth option is 8. Okay. Again I am repeating the question. At NTP, 5.6 liter of gas weighs 8 gram. The vapor density of the gas is, first option is 32, second option is 40, third option is 16, fourth option is 8. You think and answer. It is easy question. Okay. Now just to think what will be the answer. Its correct answer is C, option C, that is the 16 gram, 16. Now how? Then now I am telling you. 16 I told you, but how? Then now just you understand that 22.4 liter will have mass how much? Then 8 divided by 5.6 into 22.4 liter, because that is a 32, because 5.6 liter weight is 8 gram. Then what is the weight of 22.4? Means 1 mole. 5.6 gram weighs 5.6 liter weighs 8 gram. Then 22.4 liter how much? Then 5.6 weighs 8 gram. Then for 1, 8 by 5.6. Then for 22.4, it will become 32. Hence molecular mass will be 32. Correct? Then correct answer is 30. Correct answer is not this is 32 molecular mass. Then molecular mass is 32. Then question is asking vapor density. Then vapor density will be what? Then 2 into vapor density, that is the molecular mass. Hence vapor density will be 32 divided by 2, that is the 16. Okay, hence vapor density will be 32 divided by 2, that is 16, because molecular mass is equal to 2 into vapor density. Okay, hence vapor density will be molecular weight divided by 2, means 32 divided by 2. Now next question I am telling you. Question number 67. Which one of the following represents the formula of a substance which contains about 26% nitrogen and 74% oxygen? Correct? This also you can answer. It will take less than 1 minute time. Which of the following represents the formula of a substance which contains about 26% nitrogen and 74% oxygen? That there are 4 options is there. 4 options. First option is N2O. Second option is NO. Third option is NO2. Fourth option is N2O5. Again I am repeating the question. Which of the following represents the formula of a substance which contains about 26% nitrogen and 74% oxygen? Option 1 N2O, option 2 NO, option 3 NO2, option 4 N2O5. Just to think and then you can answer. It's a correct answer. Its correct answer is, first I will solve it, then I will tell you answer. That is the 26% nitrogen is there and 74% oxygen is there. Then here oxygen is 20. Actually you have to solve for all. In N2O how much nitrogen and oxygen is there, that you have to calculate. N2, N is equal to 14, you know. Then N2O means 14 into 2, 28 plus 16. Then 28 plus 16. That you have to add. Then you will get the molecular mass. Then this molecular mass contains 16 gram oxygen. Correct? Then then you can calculate the percentage of nitrogen. You can calculate in this compound how much nitrogen is there. Like that way you can calculate for NO. You can calculate for NO2. You can calculate for N2O5. Then you will find that percentage of nitrogen in N2O5. You will get that N2O5 means 14 into 2, 14 into 2, 28, plus O5 means 16 into 5, 80. 80 means total 108. 108 108 gram, 28 gram is nitrogen. Then in 100, how much? It will become roughly 26%. Roughly 26%. Then this is correct. Means option D is correct, because after solving this, in case of N2O5 only, it is coming roughly 26%. In other option, it is not coming 26. Okay, here roughly 26% is coming. Hence, correct answer is option D. Okay, now next question I am telling you. Okay, question number 68. Question is 10 gram of an hydrofluoric acid. 10 gram of hydrofluoric acid 10 gram of hydrofluoric acid was not 10 gram hydrofluoric acid gas occupies 5.6 liter of volume at STP. If the empirical formula of the gas is HF, then its molecular formula in the gaseous state will be: first option is HF, second option is H2F2, third option is H3F3, fourth option is H4F4. Now think and answer. Again question I am repeating. 10 gram of hydrofluoric acid. 10 gram of hydrofluoric acid gas occupies 5.6 liter of volume at STP. If the empirical formula of the gas is HF, then its molecular formula in the gaseous state will be how much? First option is HF, second is H2F2, third option is H3F3, fourth option is H4F4. Then now it is actually easy. Within 1 minute you can solve it. Then its answer is option B, means H2F2. Now how? Then for that you have to think. 10 gram HF, hydrofluoric acid gas, means HF gas, 10 gram. Its weight is 5.6 liter. 5.6 liter. Then now easily you can calculate molecular mass, that is the 1 mole means 22.4 liter. Then 5.6 gram weighs 10 gram. Then 2.4 gram how much? It will come 40 gram. Then 40 gram is the molecular mass. Molecular mass is 40 gram. Okay. Hence what will be the molecular formula? Molecular mass you calculated 40 gram. Then what will be the these things molecular formula? Then it will be H2F2. H2F2. Correct? Just to calculate H2F2. H2 means 2 gram and fluorine it will become 38, total become 40, okay. Total molecular mass is 40, it means H2F2, then 2 gram in that hydrogen is there, then 38 gram is F2, correct, F2. Then now that is the it's a molecular formula will be H2F2. Empirical formula HF, you know, 1 plus 19. Molecular formula of HF is 1 plus 19, means 20. Then 40 divided by 20, that is equal to 2. N is equal to 2. Correct? N is equal to 2. 40 divided by 20, because empirical formula is HF. The 1 plus 19. 1 is for hydrogen, 19 is for fluorine. 20. Then 40 divided by 20, that is N is equal to 2. Correct? And the molecular formula will be HF whole 2. That is the H2F2. Now, next question I am telling you. 69. Question number 69. How many atoms are present in a 1 mole of H2SO4? 1 mole of H2SO4. Then now it is also easy. It is also easy. Within 1 minute you can answer, you can solve it. First here you think H2SO4. How many atoms? How many atoms are present in a mole of H2SO4? In 1 mole of H2SO4, a mole of, how many atoms are present in a mole of H2SO4? Then now H2SO4, how many atoms are there? Just to count. H2, 2 atom hydrogen, 1 atom sulfur, 3, and 4 atom oxygen. Then it become how much? 4, 5 plus 2, 7. 7 atoms are there. Then now in 1 mole H2SO4, what will be the number? That is the total H2SO4 will be how many molecules? Then Avogadro number. Correct? Then now here 7 molecules are there. In 1 molecule, in 1 mole H2SO4, in 1 mole of H2SO4, how many molecules are there? Then that is that Avogadro number. And in one molecule, how many atoms are there? Then 7. Then what will be the total number of atoms? Then 7 into Avogadro number, means 7 into 6.02 into 10 to the power 23 atoms. Hence the correct answer is 7 into 6.02 into 10 to the power 23. Option actually it is given, 4 option. First is 3 into Avogadro number. Second is 5 into Avogadro number. Third is 6 into Avogadro number. Fourth is 7 into Avogadro number. Then the fourth option is correct. Here Avogadro number means 6.02 into 10 to the power 23. Hence question number 69, its option is D. It is very easy. Next question I am telling you, an oxide of iodine, I, that is a 127, atomic mass is 127 for iodine. It is given in question. An oxide of iodine contains 25.4 gram of iodine and 8 gram of oxygen. An oxide of iodine, I value is 127, contains 25.4 gram of iodine and 8 gram of oxygen. Its formula could be, you have to tell the oxide formula. First option is I2O3. Second option is I2O. Third option is I2O5. Fourth option is I2O7. Which one is correct? You have to tell. Okay. I say it is also easy. It is also easy. Within 1 minute you can answer. 30 seconds also you can tell. 1 minute maximum, less than 1 minute. Then just you have to calculate. Iodine atomic mass is given 127. Then its oxide, iron oxide of iodine contains 25.4 gram of iodine and 8 gram of oxygen. Its formula could be what? Then I told you its correct answer is I2O5, iodine pentaoxide, I2O5, option third. How? You can calculate it very easily. See, 48 gram oxygens are combined with 254 gram of iodine. Okay, by the question. In question they have given, it contains 25.4 gram of iodine and 8 gram oxygen. It is reacted only, and iodine atomic mass is 127 given. Then only on that basis you can calculate that option wise you can calculate. Option wise, option first you can see I2O3. I2O3 means 48 gram. 48 gram oxygen is reacting with I2. 48 gram oxygens are combined with I2 means 127 into 2, 254 gram. 48 gram. Then 8 gram, it will react with 254 divided by 48 into 8, that is the 42.3. Correct? 48 gram oxygen combined with 254 gram iodine. Then for 1, then for 8. It will come 42.3 gram. Okay. Option B. Option B. But here question they have given that 8 gram, 25.4 gram of iodine combines with 8 gram of oxygen. And you have to tell the oxide. Then now, here you have seen, you have calculated now that 8 gram, 48 gram, first option, it is combining with 42.3 gram, 42.3 gram iodine. That is not the correct answer. Okay. Because it is you have to calculate. It should combine around 25.4 gram. It should come, but it is coming 42.3. Hence, it will be not the answer. Second is I2O. It means 16 gram is reacting with 254 gram. That is also not correct. Correct? It should come 24. According to the question, it should come 25.4. But it is now second option. It is coming 127 into 2. That is the 254. That is also not correct option. Not correct. Third option is 80 gram is reacting I2O5. Then O5 means 5 into 16. 80 gram is reacting with 254. 80 gram oxygen combined with 250 gram oxygen. Hence 8 gram will combine with how much? 25.4. This is the correct option. 25.4 is coming. 80 grams oxygen are combining with 250 gram. Then 1 gram how much? 254.80. Correct? Then 8 gram, 254 divided by 80 into 8. It will come 25.4. 4. Hence correct answer is I2O5, iodine pentoxide. Option C. Option C. Now next question I am telling you. 1 liter of a gas at a pressure of 10 to the power minus 6 millimeter of Hg at 25 degrees C. How many molecules are present in the vessel? First, again question I am reading you. 1 liter of gas at a pressure of 10 to the power minus 6 of Hg at 25 degrees centigrade. How many moles are present in the vessel? First option is 3.2 into 10 to the power 6. Second option is 3.2 into 10 to the power 13. Third option is 3.2 into 10 to the power 10. Last option is 3 into 10 to the power 4. Means 3.2 is common. Only 10 to the power is different. First is 10 to the power 6. Second is 3.2 into 10 to the power 13. Third is 3.2 into 10 to the power 10. Fourth is 3. Fourth one is 3 into 10 to the power 4. And first one is 3.2. Okay, 3 options are in the 3.2. Last option is 3 only 3. 3 into 10 to the power 4. Then now you have to tell correct answer. Okay, its correct answer is actually 3.2 into 10 to the power 13. But how? Then here to solve it, you have to use P1 V1 divided by T1, that is equal to P2 V2 by T2. That formula you have to use. P1 V1 by T1 is equal to P2 V2 by T2. Then here in question it is given pressure 10 to the power minus 6. Then 10 to the power minus 6. Volume is 1 liter, already given question. 1 liter means 1000 cc, because pressure is in mm. Hence volume we should write in ml. Then P1 V1 is equal to 10 to the power minus 6. V1 is equal to 1000 and T1 is given at 25 degree, means 298. Then you have to find out number of molecules. Then here P2 V2, this P1 V1 T1 value you have written, that is equal to P2 V2 by T2. Then here P2 is equal to 760. Volume you have to calculate into V2 and divided by temperature, that is the 273. Hence by cross multiplication V2 value you can calculate. It will come 1.2 into 10 to the power minus 6 cc at STP. Then volume now you are knowing. Then number of molecules you have to calculate. Then here 22,400 molecules is equal to this thing. You have to divide by 22,400. Whatever volume has come, 1.2 into 10 to the power minus 6 cc. Correct? This is the volume. Then here you know that 22,400 cc means how many molecules? Avogadro number. Then for 1 mole, then for 1 ml how much? And then for 1.2 into 10 to the power minus 6, what you have calculated? V2. Then after solving, you will get 3.2 into 10 to the power 13. That I am telling you steps it will come, because 22,400 ml is equal to Avogadro number. then for 1 ml, then for V2 ml. You have calculated V2 ml 1.2 into 10 to the power minus 6. Then you will get number of molecules, that is the 3.2 into 10 to the power 13. Okay. Next question I am telling you, question number 72. Normality of 2mH2SO4, 2m, molarity M, capital M. Normality of 2mH2SO4 is, it is very easy, direct answer you can tell, 2m. Then you know that H2SO4 molecular weight is 98, and 98 divided by 49. 49 is the normality, you know, or you can tell H2SO4 its molecular mass is 98, and here replaceable hydrogen is 2. Then 98 divided by 2, that is the normality. Okay, 49. It will become 98 divided by 2, 49. Okay. Then here m is equal to 2n. m is equal to 2n. Then here is a 2m. Question is given 2m. Then 1m is equal to 2n. Then 2m is equal to how much? You can easily calculate. That will come 4n. 4n. Because 2m H2SO4 means 2 mole. And 1 mole means 98 gram. Then total it will come 2 into 98 gram. And 2 into 98 gram divided by 49 gram. Normality of H2SO4 is 49. 49 gram equivalent per liter. Okay, 49 is equivalent mass actually. Equivalent mass is 49. You divide by 49, then 2 into 98 divided by 49 gram equivalent per liter. It means it will come 4. 4 gram, 1 gram equivalent means 1 n. 1 gram equivalent means 1 n. Then 4 gram equivalent per liter means 4 n. Next question is 73. A compound contains 69.5% oxygen, 30.5% nitrogen, and its molecular weight is 92. The formula of the compound is how much? That also it will take hardly 1 minute time. Okay. Again question I am reading. A compound contains 69.5% oxygen and 30.5% nitrogen, and its molecular weight is 92. Molecular weight is 92. The formula of the compound is, 4 options are there. First option is N2O. Second option is NO2. Third option is N2O4. Fourth option is N2O5. You have to tell correct option. It is also very easy. Then it's a correct actually correct formula will be N2O4. Now how? I am telling you now. That percentage is 69.5% oxygen and 30.5% nitrogen, and molecular weight is 92. Then here that you have to use the, you can say one relation is there, element divided by n. Element divided by n. That is the percentage of element. Percentage of element divided by, actually you have to calculate element wise. Then what is the percentage? That is 30. Nitrogen is 30.5%. Oxygen is 69.5%. Then element wise, just atomic weight divided by divided by this. You have to tell the atomic this mole you can tell. You have to divide by mole. At percentage atomic weight. Percentage atomic weight. You have to calculate first atomic weight. Then mass is 30.5. 30.5% nitrogen. Nitrogen atomic weight is 14. Then how many moles? The number of percentage atomic weight you can tell. The 30.5 divided by 14. That will be 2.18% atomic weight. 30.5 divided by 14. It will become that is equal to 2.18. That is the percentage atomic weight. And for oxygen, same way. 69.5 is there. Then 69.5 divided by 16. It will be 4.34. That is the atomic weight of oxygen. 4.34%. Then now both are in fraction. You can convert in ratio. 2.18 you can write as a 2, and 4.34 you can write as a 4. Then ratio will be, that is the 2 and 4 means 1:2. 1:2 means nitrogen will be N, oxygen will be 2. But here you have to see empirical formula of NO2. Now you calculated 1:2 ratio. Then NO2, its empirical formula weight is 46. Empirical formula, now just you calculated that it is a NO2. Molecule is NO2, 1:2 you have calculated. Then NO2 empirical formula will be 14 plus 32, that is the 46. Then now according to the question, N is equal to how much? That molecular weight is given 92. Then empirical formula, now you calculated 46. Then 92 divided by 46, that is equal to 2. N is equal to 2. Hence molecular formula will be how much? NO2 is the NO2, now it will come N2O4. Hence molecular formula will be N2O4, because empirical formula was NO2 and N is equal to 2. 92 divided by 46. Hence molecular formula will be 2 into empirical formula, N2O4. Now last question I am telling you. The number of molecules in 1 mole of gas at STP is known as what? Now it is very easy. Direct question is there. Question number 74. I am talking about the number of molecules in 1 mole of gas. 1 mole of gas at STP is known as. First option is Avogadro number. Second option is Berzelius number. Third option is Gay-Lussac number. And fourth option is Loschmidt number. Then it is well known that this question is very popular. Now this question will be, you should not confuse with Avogadro number. Here you have to understand the number of molecules in 1 mole, not 1 mole, 1 ml. In 1 ml, mole was clear. Here is a 1 ml, milliliter, ml. the number of molecules in 1 ml of a gas. If it was mole, then its correct answer was Avogadro number. But it is the in 1 ml, milliliter, 1 milliliter of a gas. Then it is direct answer is there. That is the Low-Schmidt number. Option D, Low-Schmidt number. This is that number of molecules in 1 ml. 1 ml of gas at STP. Okay. Then this is very easy. The number of molecules in 1 mole of gas at STP is known as Low-Schmidt number. Okay. Now I am stopping only here. Next class again I will continue. Thank you.